Good evening, everyone. Thanks for taking time to join us for this webinar. My name is Thomas Andersen, and I'm a senior specialist at SEGES, located in Denmark. I'm delighted to bring you tonight's webinar on carbon footprint of the milk. Our presenters today is Jean-Baptiste Dole and Catherine Brocas from the French Livestock Institute. Tonight's webinar has been delivered as a part of the EuroDairy network. This network includes 14 countries from Ireland to Poland and Sweden to Italy. It aims to pull farmers at the center of practice-based innovation by sharing knowledge and solutions. You can find out more about EuroDairy by visiting our website eurodairy.eu. Tonight's webinar is proven popular with nearly 90 registrations from dairy farmers, vet, nutritionists, consultants, and researchers from 8 countries across Europe and the world. Jean-Baptiste and Catherine will run through their presentations and it will take around 14 minutes, and there will be time for comments and questions at the end. You will all stay muted throughout the webinar, but if anyone would like to ask a question, then please type in your questions in the box on the left-hand side of your screen. I will ask the questions at the end of the presentation. We will aim to finish up within an hour. I would like to thank our digital manager at AHDB, Sivan, who's working behind the scenes to get this webinar running as smooth as possible. But please bear with us if we encounter any technical difficulties. We will try to keep this to a minimum. So without further delay, it's over to you, Jean-Baptiste.
Okay, thank you, Thomas. So we will present you with Catherine the carbon initiative launch in France in the dairy sector. First, we will come back on the different objectives, and we will present the initiative. We will have a look also on the environmental assessment tool named Capture, and we will give you first feedback on the French milk carbon footprint after assessing more than 4,000 dairy farms. We will present you the mitigation practices suggested to farmers. And before finishing, we will present you the low carbon dairy farm project, which involves all the farmers in France. So first, I just want to come back on these figures to give you an overview on the greenhouse gas emissions from the dairy sector in France. So you have here the different sources in greenhouse gas emissions. So the greenhouse gas emissions from feed and fertilizer, from energy consumption, the emissions from manure, from soils, and the enteric fermentations. And we did an evaluation in 1990 and in 2010. And you can see that we have a reduction in greenhouse gas emissions from the dairy sector. And you have to have in mind that we didn't have a reduction in milk production in these 20 years. So that means that we reduce the milk carbon footprint by 23%. So in 1990, the milk carbon footprint was 1.4 kilo of CO2 per kilo milk. And in 2010, the milk carbon footprint is near 1 kilo of CO2 per kilo milk. And this reduction has been permitted by an increase in the milk yield and by reducing the use of fertilizers in farms. And so after doing this evaluation, we fixed an objective. And this objective is to reduce by 20% the milk carbon footprint for 2025. And so our objective is to have a milk carbon footprint in 2025 near 0.8 kilo of CO2 per kilo milk. And so regarding this evaluation, at the national scale, we launched a program with the objective to reduce the milk carbon footprint. And so our objective is to have a look on the greenhouse gas emissions, but also on the carbon sequestration permitted by livestock production. And we know that this is a complex phenomena. This is a complex subject. We have different sources of greenhouse gas emissions in farms. And it's why we think important to implement knowledge on environmental burdens and dairy farming. And this is important for us to highlight the link between practices on farms and greenhouse gas emissions. And it's why we trained a lot of advisors and farmers on the link between practices and greenhouse gas emissions. And after doing the first assessment on a large number of farms, we are now able to disseminate some low carbon practices. We will have a look after on these carbon practices. And to implement these practices in farms, we developed a national strategy and multi-stakeholder partnership. It's why in 2012, we launched the Carbon Dairy Initiative. And so to assess the environmental performance on farms, we developed two tools. The first one is named Self-CO2. So this is a self-assessment tool for farmers. The objective is to permit to farmers to calculate, to determine their greenhouse gas emissions and their carbon footprint. So the objective is to increase awareness. And this is a simple tool with 29 activity data to assess the carbon footprint. And we have another tool named Cape2R. This tool is dedicated to advisors. And so the objective with this tool is to create a national observatory. You will see the results after. And this tool will permit also to build some mitigation action plans in the different farms involved in the initiative. The two tools are following LCA analysis at farm scale, so from cradle to farm gate. And so on the farms, we will determine the carbon dioxide emissions from inputs, from fertilizer, from feed consumption, feed basket, from the fuel consumption, the electricity consumption. And we also quantify the methane and nitrous oxides from manure management, the methane emissions from cattle, and so in the barn during manure storage and for the crop management. And in parallel, we also quantify the carbon sequestration in relation with pasture management, in relation with crops management. The tool is now used in dairy production, in beef, and in sheep production. And if the program Carbon Dairy is focused on greenhouse gas emissions, we also have a look on the other environmental burdens to avoid transfer between the different environmental burdens. It's why, as described before, we calculate the greenhouse gas emissions, methane, nitrous oxide, carbon dioxide, but we also quantify the quantity of ammonia emitted from the farms, and so in relation with air quality and the acidification. We also quantify the nitrates leaching in relation with eutrophication and water quality, and we calculate the energy consumption. And to highlight the positive role on the livestock production and the positive contribution, and also to discuss with farmers, we calculate the carbon sequestration, the contribution of the farms, of the dairy farms, to the biodiversity and the food performance of the farms. And when we have to build a carbon action plan, we have to make sure that the mitigation practices we submitted to the farmers, we ask to the farmers to apply. We want to make sure that these mitigation practices are in accordance with the economic performance of the farms and with the work conditions. It's why we also have some durability indicators in the tool. Concerning the greenhouse gas emissions, Cape2R is following IPCC methodology. from tier 2 to tier 3. So you have here the different equations to calculate the methane, nitrous oxide, and carbon dioxide emissions. This is important to say that the tool is in accordance with the different guidelines. So the LEAP guidelines on large ruminants, the IDF guidelines, which describes the carbon footprint calculation. And with Agribalise, this is a French database, and so we developed a methodology in France to calculate the environmental footprint of agricultural products. And last year, we asked to EcoCert Environment to certify the tool, and so the Cape Tour tool is now certified by EcoCert Environment. You say that we have different tools used in Europe and at a global scale, and to make sure that the Cape Tour tool used in France is consistent with the other tools, we did some comparison in dairy production. 2 years ago, we did a comparison with Overseer. This is a tool developed in New Zealand to assess the dairy and beef farms. Recently, last year, we did a comparison with the Cool Farm tool, developed by Wageningen University for Unilever. And in the next months, we want to do a comparison with the tool developed in USA. And we are doing now a comparison also in beef production. So with the Carbon Navigator in Ireland, developed in Ireland, and Bovid CO2 developed in Spain. And you can see on the chart the correlation. You have here the results obtained on 15 farms. And we compare here the results. So this is the greenhouse gas emissions in kilo of CO2 per dairy farm, and you can see the result obtained with Cape Tour level 1 and the result obtained with the Cool Farm tool, and we can see that we have a high correlation between the two tools. Concerning the carbon sequestration, you know that we don't have any common methodology to assess the carbon sequestration. But we, in France, we absolutely want to evaluate the carbon sequestration, to discuss with farmers and to show them they are contributing to store carbon in the soil. So it's why we developed a methodology with some technical options from bibliography. And so for the carbon storage in permanent pasture, for example, we have a factor for stocking carbon of 570 kilo of carbon per hectare per year. When you plug a grassland for cropland, we have some carbon release with 160 kilo of carbon per hectare per year. And we also consider the carbon sequestration. For example, when we have a crop between two main crops, we have a carbon sequestration of 240 kilo of carbon per hectare per year with agroforestry and with ages. And so we compare the carbon sequestration to the greenhouse gas emissions in each farm. And so with this tool, with this methodology, our objective is to involve farmers step by step in a carbon strategy. It's why we suggest to farmers, to advisors, to be aware, to be informed on the greenhouse gas emissions. And we suggest to farmers to do a self-assessment analysis. And we have now 1,300 dairy farms assessed with the self-CO2 tool. And after this simplified analysis, we submitted to farmers to have a diagnosis with an advisor. And so we use a Cape Tour tool with the two levels. We have a simplified level with 39 activity data, and a complete analysis with more than 150 activity data. The first level is to highlight the carbon footprint of the farms. of the different farms. The second level is really to permit farmers and advisors to build a carbon action plans. So this is the next step, and to suggest to farmers to apply some mitigation practices. And so to date, we have 9,000 dairy farms assessed with the tool, and Catherine will present you the different results obtained on these farms. And so we will ask now to Catherine to present the different results.
Okay. Hi everybody. I will show you the results of the program EuroDairy. So the program is an association with 14 partners, and the objective is to reduce the milk carbon footprint at farm level by 20% over 10 years. The partners of the programs are key players in the French dairy sector, with Dairy Advisory Enterprise, Chamber of Agriculture, and the French Dairy Board. And the project was conducted on 6 different pilot regions, which are representative of the French dairy industry. These 6 regions account for 65% of the milk delivery and are representative of the different climate condition and feeding strategy of the French dairy production. So we work with 200 advisors, and almost 5,000 farmers were involved in the project. We began in 2013 and finished this year, and we realized 2 diagnoses on the farms. When we realize a diagnosis on the farm, we collected on annual basis the technical data, and we present the result of the farmer and try to find practices to improve the milk carbon footprint. So the questionnaire consists of 150 questions divided in 6 sections regarding herd demographics on milk production, animal housing and manure management, crop production for on-farm produced feed, feed ration and feed purchased, on energy consumption, fuel and electricity. So with all this data, we can calculate the milk carbon footprint. And all the work take around 2 or 3 hours with the farmer to get the results. So our farm sample, the average dairy farm was 95 hectares, and only 64 hectares were dedicated to the dairy herd, and we produced 467,000 milk. The milk production per cow is 7,500 milk a liter. There is maize, a lot of maize in the forage system, with 37% of maize. And concentrated humus is 166 grams per liter, and nitrogen fertilizer humus is 145 kilo of nitrogen per hectare. So this sample is not representative of the different of the French average dairy farm, because of the Western systems, which represent 80% of the sample. So the systems are very intensive, using maize and producing more milk per cow than the mountain grass based system. So here are the results. On the farm, the average GIG emission is more than 1 kilo of CO2 per liter of milk. The GIG emissions are compensated by 11%. So the net carbon footprint is 0.93 kilo of CO2 per liter of milk. So the major contributor to GIG emission is the enteric methane, which represents 51% of the GIG emission. The next largest contributor is manure management with storage and grazing cattle, which produce methane and nitrous oxide, and it represents 18% of the GIG emission. And after, we have the fertilizer application, feed purchasing, which each one represents 11% of the GIG emission, and the energy inputs, fuel and electricity, represent 5% of the emission, and the fertilizer purchasing and cattle purchasing represent 4% of the emission. As you can see here, there is no significant difference among forage systems. In France, we have 5 systems, 3 systems of the plain and 2 which are regrouped in mountain. And we have grass systems which are less than 20% of maize in the forage area. The mixed system, which are less than 40% of maize, and the maize system, which have more than 40% of maize in the forage system. So what you can see here is that there is no difference between systems in GIG emissions. And when we look at the carbon sequestration, which is associated with the grassland on the edges, there is 11% of compensation with carbon storage, but there is a lot of difference between the different systems. With the plant system, which compensate between 6 and 21% of their emission, and the mountain system, which can compensate till 50% of their GIG emissions. So here you can see that there is a part the crop don't stock carbon, but this is compensated by the hedges and grassland carbon storage. So as we see, there is no difference between production system for GIG emissions, but there is a higher difference between efficient farm and less efficient dairy farm. So here the mean of the sample is around 1 kilo of CO2 per liter of milk, and the best farmer, which have the lowest GIG emission, have a result of 0.85 kilo of CO2 per liter. So, since the objective of the study is to identify the management practices that could be efficient to reduce the milk carbon intensity, the relationship between the milk carbon footprint and farm practices were tested using a correlation analysis. And here you can see the practices which explain the variability between the farm about the GIG emission. So we find no correlation with farm size and number of cows, but the most important correlation were with milk production per cow, age at first calving, and concentrate rate used by the dairy cow. The hover indicator replacement rate and nitrogen fertilizer use explain the variability of the GHG emission, but they are less important than the free hover. So to complete the analysis and to confirm the observation, we regard the result of the farmer, the 10% of farmer which have the lowest GHG emission. And as you can see, it confirms the result we saw just before, that the milk production explains the difference. There is almost 1,000 liter of milk per cow of difference between the mean and the best performers. For the and they use less input than the mean, as they use only 146 grams per liter of concentrate, as the mean use 166, and they use less nitrogen fertilizer with 122 kilo of nitrogen per hectare, as the mean they use 145 kilo of nitrogen per hectare. So as you can see, there is a big difference in GHG emission, as the mean is more than 1 kilo, and the best performer in GHG emission are 0.87 kilo of CO2 per liter of milk. But as you can see, the carbon sequestration is a little reduced between the mean and the best performer in GHG emission. So milk production, number of heifer, and nitrogen crop management as the main mitigation practice on the best farm for the GHG emissions. And when we work with the farmer on the carbon footprint, after we present the result, we have a set of practice indicators to identify strength and weakness of each farm. So we call identified practices adapted to the farm context and farmers' objectives, and we register the choice of farmer in the tool Capture. So as you can see here, the first choice for farmer to improve their milk carbon footprint is herd management practices. And so they work on heifers management, herd health, and milk yield. The second choice is the quantity of concentrate and azote excretion. So it's the feeding of the dairy herd, and they try to improve the forage quality. They try to reduce concentrate, improve protein autonomy, and use more pasture and legume in grassland. The third choice of farmer concerns the crop management with the nitrogen fertilization, with the objective to improve forage yield, fertilization, and to use more legumes in the rotation. And as you can see, the carbon sequestration, which need to implement more permanent grassland on edge, are not the first choice of farmer. They didn't want to implement edge and permanent grassland because of the cost of this practice. And some farmers try to improve fuel consumption and electricity consumption to reduce GHG emission. And we try to evaluate the reduction potential for each mitigation practice. And as you can see here, the most efficient practices, which are the herd management and the number of animals on the farm, present the best potential, and it's the first choice of farmer. On the second and third reduction potential as the quantity of concentrate on the nitrogen fertilization. All these three practices are efficiency. So as you can see, efficiency is the first farmer objective and permit to reduce carbon footprint. So it's good for the carbon footprint and it's good for the farmer. So we try to evaluate GHG emission and economic results. For more than 1,000 of Brittany farmers, we have the gross margin with the details of the product sales and variable cost. So as you can see here, we have three classes, the mean, and the best farmer, which have the lower GHG emission, and the worst farmer with the higher GHG emissions. So you can see that the gross margin is higher for the best performer in GHG emission with 241 euro per 1,000 milk produced, and the worst farmer in GHG emission only have 211 euro per 1,000 milk produced. And the difference is explained because of the variable cost. We have a difference of 30 euro per 1,000 milk between the best farmer in GHG emission and the worst farmer in GHG emission. There is no difference for the product sales. So there is a good link between the GHG emission and the economic result, and especially variable cost on the farm. And and we confirm the link with the practices, and in this table you can see the result of the mean, the best performer in GHG emission or the worst performer, and what you can see is that the milk production is almost 1,000 liters more for the lower GHG farmers, and it's almost 2,000 liter of milk with the worst farmer, and the difference is of 2 months for the age at first calving. On the concentrate rate, the best performer in GHG emission use less concentrate than the worst farmer, and they produce more milk per cow, and they use less fertilizer too. So the economic and GHG result are explained with this technical result and the efficiency of his farm. So I present you the 2013 years, and we have the result of the 2016 years. So we can do a comparison with two diagnoses of 2,300 farmers. So here as a result of 2013, and here as a result of 2016. And as you can see, the net milk carbon footprint is reduced by 6%, and it's explained by the reduction of the GHG emissions. and we explain this reduction of GHG emission because of a reduction of concentrate use and nitrogen use on the crop, with a milk production per cow which don't change between the 2 years. So there is less input with the same milk production per cow, which explain phase evolution. And we have the economic result for almost 400 farmers. And as you can see, between the 2 years, the variable cost were reduced by almost 10%, and the GHG emission were reduced by 5%. And as I said before, all these results are explained because of an improving efficiency of his farm. The milk production is a little reduced, but the concentrate rate on the nitrogen mineral fertilizer use is reduced. So there is less input, less GHG emission, and less operating cost. So, but between the 2 years, economic conditions for inputs were better in 2016. So as a conclusion, when farmers are engaged, reduction of the milk carbon footprint is possible. We have done a 6% reduction in 3 years. The improving production efficiency and reducing the carbon footprint of milk production are highly complementary with positive impact on economy. On the milk carbon footprint assessment is a good means to provide farmers with information about GHG emission from dairy system and the link with farming practices.
Okay, next slide, Catherine.
Attends, ça marche pas. Ah, ok.
So, due to the Carbon Dairy project has been launched in 2013, and so it will be finished in 2018. And as presented before by Catherine, we saw that the project concerned 6 main regions in France. And so in 2015, the objective of the French Dairy Board was to disseminate the project and the initiative on the carbon assessment, on the construction of the carbon action plan in all farms in France, in the different regions. And so the milk carbon footprint has an objective, which is to involve 50% of the dairy farmers. So we have in France 60,000 dairy farmers. So the objective is to involve 50% of these farmers in this initiative in the next 10 years. And so we have here the different producer association and industry companies involved, and the objective is to use the same tool and the same approach to involve the farmers in the initiative. Next slide. And so next slide, Catherine. And so we have now in France, so the Carbon Dairy project, so the low carbon dairy farm project, we have the same program in beef production. And so the milk and meat French board launched these 2 initiatives. The French Livestock Institute is implementing the initiatives in France at a national scale in collaboration with advisors company, as the chambers of agriculture and companies specialized in advice to farmers. And as it is a national program developed by the milk board, several companies, milk companies, private companies as Bell and Danone, and some cooperative developed also the project. and they suggest to their farmers to be involved in this initiative, to assess their carbon footprint, and in some case to implement some mitigation practices in order to reduce the milk carbon footprint as discussed before. Next slide. And so I show you before the different steps to involve these farmers. So we will adopt these different steps to involve the farmers in the initiative. And the next step, after building different carbon action plan on farms, we want to determine, to highlight the CO2 avoided by farmers. When they will implement some practices, we will be able to reduce the greenhouse gas emissions. We will be able to increase the carbon sequestration. And the objective is to monitor and to report this greenhouse gas emission avoided. And we want to implement a multi-stakeholder financing solution to support farmers. So the objective is we are developing now a methodology with the French Ministry of Environment to certify the CO2 avoided, and we know some companies interested in compensating their emission. So the objective will be to fund farmers to implement their practices with this carbon offset system. Next slide. So with this initiative, after 5-6 years of implementing this project, we have a framework on greenhouse gas emissions and livestock we didn't have in 2012. We have a huge partnership, and we think this is really important if we want to convince farmers to be involved in this initiative. We think this is really important, and so to have a high level of dissemination. This is the case with the 10,000 farms involved in. This is for us the first concrete application of actions in commercial farms. So this is not so easy for all farmers, but we see that there is a link with efficiency. So we can discuss with farmers on the link between economic aspect and environment. And this is for the beef and the dairy sector, a proactive strategy to reduce the carbon footprint, but also, as I said before, to have a look on the other environmental burdens and to increase sustainability of the dairy farms in France. Thank you for your attention.
Okay, thanks to Catherine and Jean-Baptiste. While I'm waiting for some questions to come up, I should like to remind you that tonight's presentation has been recorded and will be available to watch back on the EuroDairy website, among with other webinars from the last 2 years. The first question, you said that 23% decreases since 1990. How did number of cows change in this period?
In this period, the number of cows has been reduced by 10% approximately. So we reduce the number of cows, but this reduction has been permitted by an increasing in yield production. It's why at a national scale we have the same milk production between 1990 and 2010.
Okay, I have another question about organic farmers. Has any organic farmers been evaluated? And if yes, is there any relevant difference between the carbon footprint on the organic farms and traditional farms?
Yes, we have a result for 60 organic farms, and we have no difference in GHG emissions, but we have more carbon sequestration because we have more grassland.
Okay. Then I have a question. You have to make some registrations from the farms. how much work is it to do an assignment to measure the carbon footprint?
Sorry, Thomas, how many?
How
How
long
many?
will it take?
How long?
How much time? How long?
Okay.
And how many figures do you have to measure
Yes.
and type in?
For the complete diagnosis, it takes almost 3 hours to collect information and data and to present the results to the farmer. And when farmer is very motivated, we can do an action plan, and we need one more half a day to do the carbon action plan.
So generally, this is one day per farm to do the diagnosis and to build the action plan and to discuss the results with farmers.
And this has been paid in the project.
Yes.
Yes.
It has been paid by the project, so it was a European project funded by LIFE. And when we have some private companies or some cooperative, they developed the tool, so they pay the advisor. And we have in France any regions, administrative bodies who are interested to implement the carbon initiative, and so they fund the implementation of the initiative in farms in the regions. So we have different funding sources.
Okay. And this action plan made for the farm, what does it consist of? Is it some have to change or?
The action plan, it is a description of the mitigation practices suggested to the farmer. We give to the farmers the results of the farm with the milk carbon footprint, the eutrophication, etc. And after a comparison between the greenhouse gas emission and the practices on the farm and the referential we can suggest to the farmer to reduce the fertilizer use, to reduce IH at first calving. And so we are describing the action plan, and we can help the farmers to implement this action plan. So to adapt the system to the new practices.
Okay.
And we evaluate the cost of the action plan, the action plan to the farmer.
Mm.
And I understood right that they have decreased their cost with 9% in average.
Yeah.
Yeah, and decreased the greenhouse gas emission with 5.
Yeah, there is some solution which are cost effective, and we have another solution which represents some cost, extra cost. So that depends on, yeah.
What will the reaction be realistically? The most action will contribute to further decreasing the carbon footprint. What is most relevant to do on the farm?
It's depend on the farm and the practices that applied on the farm. But generally, if we can reduce the methane from unproductive animal, this is really relevant because the methane represents a high part of the carbon footprint. So if we can reduce the age at first calving, if we can reduce the unproductive cows, for example, if we have some mastitis, for example, this is really relevant, yeah. And after, we also reduce easily with farmers the greenhouse gas emissions. This is in relation with the fertilizer management.
Okay. This work you have done with the farmers, how many advisors have been involved in this, going back to and discuss the results with the farmers?
to date, we have 100 organizations, 100 companies, and 310 advisors trained to assess the farm and to build a carbon action plan.
And then we have a question about evidence about the herd size. Is the herd size meaning anything to the carbon footprint?
Is the herd size linked to the carbon footprint?
Yes.
No, no. The carbon footprint is really linked to the practices we can have, and so we can have small farms with a lot of inputs, a lot of unproductive animal, for example, and so the total emission will be higher, and so per kilo milk we will have a carbon footprint, a higher carbon footprint that a big farm, for example. So that's really depend on the practices applied on farm.
Okay. Then we have a question about the methodology used. How are concentrate emission calculated? So soybean or ingredients from other countries have different emission factors.
So we use some data from EcoInvent database, and we also have a new database in France for all feeds, and so we use this different database, yeah. And this database is used in France, and so for the soybean, for example, we have the data from EcoInvent. We compare the value of the different feed with some international database, and so to make sure that this value are consistent also. Yeah.
Okay. And is there any other questions out there? Then please type them in the bar on the left side.
Sorry?
There's a follow-up on the soybean. Is soybean from Brazil different from other regions?
So we know in France the origin of the soybean, and so I don't remember the carbon footprint of the soybean now, but we consider the soybean used in France, yeah. And in the soybean, we also consider the carbon release from deforestation, according the provenance.
So you have a big database with different types of
the different situation, yeah, of course, yeah.
Certainly, that's good. Any other questions? Please feel free. In Denmark, we are doing a lot of work. There's also people trying to make tools to measure the carbon footprint.
Yeah.
And where we say your model is strong, and then where's the weaknesses? If you should improve the model, what should you do if you should add some data from the farm? Do you have any consideration about that?
If we want to improve the tool?
Yes.
What we will do?
Yeah, where's your tool strong, and where could there be some weaknesses?
This is on the carbon sequestration, sure.
Yes. Okay.
Because on the greenhouse gas emissions, we well know the methodology, we compare the tool, etc. But concerning the carbon sequestration, we need a common methodology in Europe and at a global scale. It's why for the moment we decided to retain some value, some constant value. But we know that for us, we think this is important to show to farmers they are contributing to sequestrate carbon and to maintain this carbon stored in the soil. It's why it's important to discuss with us of this value. But we know that we have to improve the carbon sequestration calculation. Yes, of course. And perhaps you know that there is a guideline developed by FAO on the carbon sequestration calculation, and this guideline will help you to improve the carbon sequestration calculation. Yeah. In the next year, this is the part we have to improve. Yeah.
Okay. I don't think we have any other questions, and I think we should round up this webinar. A big thank to you all for listening. We have had a great turnout, and I think it was really interesting to see some of the figures you got from a lot of assessments in France. Please all notice that we on Thursday have another EuroDairy webinar with focus on the carbon footprint. Here we can hear why Arla Foods, dairy working in 7 European countries, are focused on measuring climate and working with sustainability, and what the farmers have gained from having their carbon footprint quantified. Arla has worked in the UK, Denmark, and Sweden, so they might have another view of it. But a very special thanks to Catherine and Jean-Baptiste for taking time to have this webinar today.
Thank you.
The recording of this webinar will be available to watch back on the EuroDairy website. All of those that are registered will receive an email alerting you when it will be live on the website. Thank you all and have a good evening.
Thank you. Bye.
Bye.